Hello students, this is Hamza Noor and today we are going to solve some more questions from the same paper 9709 A-Level Maths October-November 2021 paper 1 variant 2. Question number 1 till question number 8 is already done, and here we have question number 9 onwards. Question number 9 is from the topic rate of change, uh, differentiation. So this question is worth 6 marks. So let's start solving this. So the volume V meter cube of a large circular mound of iron ore of radius R meter is modeled by the equation V is equals to 3 over 2 multiplied by R minus 1 over 2 the whole thing cubed minus 1 for R is greater than or equals to 2. Iron ore is added to the mound at a constant rate of 1.5 meter cube per second. Part A is asking find the rate at which the radius of the mound is increasing at the instant when the radius is 5.5 meter. So according to the information which is given to us in the question, what we have is that iron ore is added to the mound at a constant rate of 1.5 meter cube per second. So this means that we have dV over dt, which is equals to 1.5 meter cube per second. Okay. And secondly, what we need is our requirement is actually at the instant when radius is equals to 5.5 meter, we need to find the rate at which the radius is increasing, which means that when r is equal to 5.5, find the value of dr over dt. This is our requirement. Okay, so first of all, in order to find dr over dt, what we are going to do is we will use the chain rule formula. So in order to find dr over dt, so dr over dt will be equals to dr over dv multiplied by dv over dt. So first of all, we need the value of dr over dv, and for that purpose, we will differentiate v with respect to r. This function is given to us volume in terms of radius. Okay, so since we know that v is equals to 3 over 2 multiplied by r minus 1 over 2 the whole thing cube and then minus 1. So first of all, we are going to differentiate v with respect to r. So dv over dr is supposed to be 3 over 2, and then this power 3 will be multiplied over here, and then r minus 1 over 2 the whole thing is square multiplied by the derivative of r minus half and then minus 1. So this is differentiated, so this becomes 0. Okay, then dv over dr function is supposed to be 9 over 2 9 over 2 multiplied by r minus 1 over 2 the whole thing is square. Now what we can do over here is at the instant when r is equals to 5.5 meter, we can actually find the exact value of dv over dr. So dv over dr is equals to 9 over 2 multiplied by 5.5 minus 1 over 2 the whole thing is square. What is the exact value of dv over dr over here? Okay, so 5.5 minus half the whole thing is square multiplied by 9 divided by 2. This is exactly 225 over 2. This is the value of dv over dr. So since dv over dr is 225 over 2, so in order to find dr over dv, we are just going to reciprocate this function, reciprocate this fraction. So this becomes 2 over 225, and the value of dv over dt is already given to us, which is 1.5. So therefore dr over dt is equals to 2 multiplied by 1.5 divided by 225. This is 1 over 75 meters per second. This is dr over dt. This was part A. Then we have the next part. Part B is saying that find the volume of the mound at the instant when the radius is increasing at 0.1 meter per second. At the instant when the radius is increasing at 0.1 meter per second, which means that the value of dr over dt is given to us, that is 0.1 meter per second. Okay, so in order to find the value of dr over dt, we have used the chain rule formula in part A, which was dr over dv multiplied by dv over dt. Now we have the value of dr over dt, which is 0.1. We don't know the value of dr over dv, so we will keep it unknown. And then multiply it with dv over dt, which is given to us already in the question, 1.5 meter cube per second. So dr over dv is supposed to be how much? 0.1 divided by 1.5. So 0.1 divided by 1.5, this is 1 over 15. The value of dr over dv is 1 over 15. Now since dr over dv is equals to 1 over 15, this means that dv over dr, we have to just reciprocate the fraction. This will be equal to 15 over 1, which is 15. Okay, we need to find the volume at an instant, and for that purpose we need a particular value of r. So first of all, we need to find a particular value of r, and for that purpose we are going to use the dv over dr function, which we have found by differentiating v with respect to r in part a. Since we know the value of dv over dr, which is 15, so we will equate this value to the dv over dr function. And since we know that dv over dr function is equals to this one, 9 over 2 multiplied by r minus 1 over 2 the whole thing square. Okay, so 15 is equals to 9 over 2 multiplied by r minus 1 over 2 the whole thing square. Okay, so if you make r minus 1 over 2 the whole thing square the subject, so this is 15 multiplied by 2 divided by 9. So r minus 1 over 2 the whole thing square is equals to 30 over 9. Okay, and 30 over 9 in its simplest form is 10 over 3. All right, so now what you need to do is find the value of r. And if you take square root on both sides, so you know what to do. R minus half is equals to plus minus under root of 10 over 3. We can first exactly we can find the exact value of r. So r is equals to half plus minus under root of 10 over 3. Obviously, half plus under root of 10 over 3 will give you a positive value of r. And since r is basically the radius cannot be negative. So r is equals to half minus under root of 10 over 3 will be completely ignored. So therefore, r is equals to 1 over 2 minus under root of 10 over 3 will be completely ignored since the radius cannot be negative. So only acceptable value of r is half plus under root of 10 over 3. Okay, this is the exact value of r. Now what you need to do is you need to find the value of volume. You can use this exact value of r as well, or you can use the value of r correct to 4 decimal places as well. Okay, so v is equals to 3 over 2 multiplied by r minus 1 over 2 the whole thing cube and then minus 1. So v is equals to 3 over 2 the constant term multiplied by 1 over 2 plus under root of 10 over 3 minus half the whole thing cube and then minus 1. So as you can see that half and minus half are cancelled out. So in calculator you can exactly write 3 over 2 multiplied by under root of 10 over 3 is whole cube and then minus 1. This is 8.1287. Correct to 3 significant figures, the value of volume is 8.13 meter cube. This is supposed to be our final answer to part B. This was question number 9. Then we have question number 10, and the topic is functions. And this question is worth 7 marks. So the question is saying that the function f is defined by fx equals x square plus k over x plus 2 for x is greater than 0. Part A is saying that given that the curve with equation y is equals to fx has a stationary point when x is equals to 2, find the value of k. So first of all, we need to find the f dash x function. We need to differentiate it. So fx equals x square plus k times x raised to the power minus 1 and then plus 2. So the f dash x function is supposed to be 2 times x raised to the power 2 minus 1 plus k times minus 1 multiplied by x raised to the power minus 1 and then 0. So 2x minus k times x raised to the power minus 2. This means that f dash x equals f dash x equals 2x minus k over x square. So for the stationary point, the f dash x function is supposed to be equal to 0. Therefore, 2x minus k over x square is equal to 0. Therefore, 2x is equals to k over x square. So 2x cube is equals to k. Therefore, x cube equals k over 2. So basically, what happens that when x is equals to 2, for example, if k was given to you, so the stationary point would have been equals to 2. So when x is equals to 2, what you need to do is just substitute x equals to 2 into this equation and find the value of k. So 2 cube is equals to k over 2. So 8 multiplied by 2 is 16. So therefore k is equals to 16. The value of k is equals to 16. This was part A. Then part B is saying that determine the nature of this stationary point. The stationary point is x equals to 2. We need to determine the nature. So we are going to find the second order derivative. Okay. Since we know that f dash x equals 2x minus k over x square, and we have found the value of k. So this means that f dash x equals 2x minus 16 over x square. Okay, so f dash x is written in this form, 2x minus 16 x raised to the power minus 2. So the second order derivative is supposed to be 2 multiplied by x raised to the power 1 minus 1 minus 16 times minus 2 multiplied by x raised to the power minus 2 minus 1. So 2x raised to the power 0 plus 32x raised to the power minus 3. So this is 2 plus 32 over x cube. 2 plus 32 over x cube. This is your second order derivative. So what we need to do is we need to substitute the value x equals to 2 into this second order derivative. So just find the value of f dash dash 2. In the f dash dash x function, just put x equals to 2. So 2 plus 32 over 2 cube. So 2 plus 32 over 8. This means that 2 plus 4, which is equals to 6. Since f dash dash 2 is greater than 0, therefore x is equals to 2 is a minimum point. X is equals to 2 is a minimum point. This is the nature of this stationary point, x is equals to 2. This is part B. Then we have part C, and it says that given that this is the only stationary point of the curve, find the range of f. Since we know that this is a minimum point on the curve, and we don't actually need to sketch this whole graph, or we are required to do so. Okay, we don't need, and we are not required to do so. But what we know, the fact is that this stationary point x equals to 2 is a minimum point. Okay, let's just say that this is x is equals to 2, and this is a minimum point on the curve. And let's say a little part of the graph is just like this. Just assume that it is like this. Okay, so I mean the range of the graph would be greater than or equals to obviously this certain value, isn't it? Because this stationary point is also included over here. Okay, x equals to 2 is also included, so obviously the corresponding value of y will be included in the range, and range would be something like this, that f range would be fx is greater than or equals to f2. But what we need to do is find the value of f2 into the fx function. What you need to do is just substitute x is equals to 2, so fx equals x square plus k over x square plus k over x, and the value of k is 16, so x square plus 16 over x and then plus 2. So just find f2, which is 2 square plus 16 over 2 and then plus 2. So this is 4 plus 8 plus 2, so 8 plus 4 is 12, 12 plus 2 is 14. This means that range is that fx is greater than or equals to 14. This is supposed to be your final answer for 2 marks. This was question number 10.